When replacing a 15-amp single-pole ground fault circuit interrupter breaker in a Challenger SB20 30-40 cm Mod 1 panel, adherence to the panel manufacturer's specifications is paramount. The panel's labeling indicates approved breaker types, such as Challenger or Sylvania Type A, C, HC, or HAG breakers. Substituting breakers with those not explicitly listed or approved by the panel manufacturer can lead to several potential issues. Firstly, physical compatibility problems may arise. Breakers from different manufacturers often have varying dimensions and connection configurations. This can result in a breaker not fitting properly within the panel's busbar assembly or not making a secure electrical connection. An improper fit can lead to loose connections, arcing, and overheating, which are all significant fire hazards. Secondly, electrical incompatibility is a major concern. Breakers are designed to trip at specific current levels to protect circuits from overloads and short circuits. Using a breaker with a different tripping characteristic than what the panel is designed for can compromise the system's protection. For example, a breaker that trips at a higher current level might allow an overload to persist for too long, potentially damaging wiring and appliances. Conversely, a breaker that trips too easily might cause nuisance tripping, disrupting power unnecessarily. Thirdly, listing and labeling requirements must be considered. Electrical panels and breakers are typically tested and listed by independent testing laboratories like Underwriters Laboratories, Intertek, or Canadian Standards Association. This listing ensures that the equipment meets specific safety standards and performance requirements. Using a breaker that is not listed for use in a particular panel can void the panel's listing, potentially creating liability issues in the event of an electrical fire or other incident. Furthermore, insurance companies may deny coverage if non-approved components are used. When faced with the need to replace a breaker and compatible options are not readily apparent, consulting the panel manufacturer directly is advisable. The manufacturer's technical support department can provide information on approved replacement breakers or suggest suitable alternatives that meet the panel specifications. Another valuable resource is a qualified electrician. Electricians have the training and experience to assess the electrical system, identify compatible components, and ensure that the replacement is installed safely and correctly. They can also verify that the replacement breaker meets all applicable electrical codes and regulations. In cases where a direct replacement isn't available, an electrician may be able to modify the panel or circuit to accommodate a different type of breaker. However, such modifications should only be performed by a licensed professional and must comply with all applicable codes and regulations. It is also crucial to understand the function of a ground fault circuit interrupter breaker. A ground fault circuit interrupter breaker is designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. Ground fault circuit interrupter breakers are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. When selecting a ground fault circuit interrupter breaker, it is essential to choose one that is specifically designed for the intended application. Ground fault circuit interrupter breakers are available in different trip levels, typically 5 mA or 30 mA. A 5 mA ground fault circuit interrupter breaker is more sensitive and provides greater protection against electrical shock. A 30 mA ground fault circuit interrupter breaker is less sensitive and is typically used for equipment protection. When installing a ground fault circuit interrupter breaker, it is important to follow the manufacturer's instructions carefully. The breaker should be properly connected to the circuit and tested to ensure that it is functioning correctly. Regular testing of ground fault circuit interrupter breakers is recommended to ensure continued protection. In summary, replacing a breaker in an electrical panel requires careful consideration of compatibility, listing, and safety requirements. Consulting the panel manufacturer or a qualified electrician is essential to ensure that the replacement breaker is suitable for the application and meets all applicable codes and regulations. Failure to do so can result in serious electrical hazard. Therefore, it is always best to err on the side of caution and seek professional assistance when dealing with electrical systems.